All right. Hello, everyone. This is Mr. Ferrick. I am not there, so I'm going to kind of run through a little bit of these, maybe not notes. We've already done these notes, but I wanted to run through the 6.2 independent and dependent tasks that you may have started, but I wanted to maybe throw you a couple of them, or maybe all of them, not sure yet. I'll see what I want to run through here. As to how to do them, I think this is a little bit of a time where we need to see what's going on with probability. This is kind of the heart of what we're doing, so it'd be really important to know how to set these up. As we said before, independent events are ones that stand alone and they are not affected by results. So if I roll a dice, I have a 1 of 6 chance. And if I flip a coin, I have a 1/2 chance. They don't really affect each other, but dependent events are affected by other things. So if I pull a card out of a deck, I have a 1 out of 52 chance. But if I take it out, right, if I put it aside, I then have a 1 out of 51 chance to pull the next card. Like, we're losing amounts of cards, and that's when you take a card out and don't put it back, right? So that would be the difference between the two, is where one is just their normal probabilities, and the other is if they're affected. Now, when I do this, something I should probably tell you too, and it says it down here, is that you multiply them. So it would be a 1/12 chance that you roll maybe a 3 and getting a heads or something like that. And then this is obviously going to be quite a big number. So I'm going to make sure I have my calculator ready, as you should, to change some of those decimals or fractions or whatnot to be ready to go. All right, so we did all these practices together. Let me talk about these tasks real quick. Maybe I'll give you a few, and then maybe you could try the remainder of them in each task. Maybe that's what we'll do. All right. So as part of a board game, and you see my nice little colors over there, the spinner, you need to spin the spinner, which is divided. So when you spin the spinner a couple times, let's say I want to get a 1. What if I spin it again? Like, it's still a 1 of, and then how many sections are there? There's 8 of them. So if there's 8 of them, I have a 1 in 8 chance to land on any of those different spots. So does 2 spins affect each other? I would say no. So I'd say it's independent. I'll just circle it there, right? So if I spin it once, it's 1 of 8. If I spin again, it's still 1 of 8. So it doesn't really affect the second spin, obviously. Find the probability that you land on a 5 on your first spin. Okay, so there's only 1 5 on here, and there are 8 slots. So 1 of 8 times, now you got to do your second spin, which will be landing on a 3. So what's probably landing on 3? Well, there's only 1 3 on here, right? So that seems like it would be 1 of 8 again. There's only 1 spot that's a 3, and there's 8 separate slots. So you'd say it's 1 over 64, right? Because I multiplied the 1s on top. 8 times 8 is 64. Cool. All right, I'll let you do C maybe, and then I'll do D. How about that? So I'll do these too. You do the others. Well, I did the first one, I guess, too. What is the probability your spin is an even number and then an odd number? All right, so the even numbers, let me reset this one. Even numbers are going to be 2, 4, 6, 8. So it looks like there are 4 spots out of 8 for the first one, times, and then how many odd numbers are there? Well, the odd numbers would be 1, 3, 5, and 7. So there's 4 more slots. So it'd be 4 of 8 again. And like I said before, I think it would be good to maybe simplify these before you multiply them out, because some people will get 16 out of 64, which is fine, I guess. But what if you change these to something simpler? Aren't they both 1/2? 4 divided by 4 is, divide them both by 4, right? So it'd be 1/2 times 1/2. 4 over 8, it's the same thing, right? So it'd be 1 over 4, and some people, decimals, would say it's like 25%. Nice. Just keep in mind, if you're doing this one, numbers greater than 6 would be like 7 and 8, right? Like, you don't want to include 6, so there's only 2 options there. Just good to keep in mind. All right, I'll let you do that one, though. All right, onward. Let's do task 2. If a fair coin flip and a die is rolled, what is the probability of getting tails and rolling a 3? So what is the probability of getting tails? That's the first event. I would say that there is one way to get tails and 2 options on a coin. So it's 1/2. And then the second event, remember we're multiplying, there's only one way to roll a 3 out of how many options on a dice? 6. So I need to do 1 times 1 and then 2 times 6. I already kind of showed this one actually. It would be 1/12. Pretty good. Let's see, which one do I want to do? How about I do this one here, another greater than kind of thing, or less than. So a coin is flipped, dice is rolled. What is probably getting tails again? Well, we already said that one, 1/2 times. Okay, and then this is where people could get lost a little bit. Rolling a number less than 6. What are the numbers less than 6? Well, 5, 4, 3, 2, and 1. So those would be 5 numbers out of 6 numbers. And so now you can't simplify these again. So I'm going to go 1 times 5 is 5, 2 times 6 is 12, and that would be my answer. Not so bad. All right, you do the other 2. All right, there's some pulling out some socks out of some drawers. Let's do this guy. 4 blues, 6 reds, 10 purples. So it looks like you should first probably take the total amount, and I'd say that would be 20. 4 plus 6 plus 10, right? Without looking, Larry randomly pulls out the red sock. Okay, so how many red socks are there? Looks like 6. So I'm going to put 6 up here, times, and then pulled out another red sock. Okay, so this is where it's going to be a dependent variable, not an independent variable anymore like this. These are all independent because they didn't affect each other. These will probably be dependent because you're taking socks out of the drawer. It's going to affect the second one. So how many socks are left? Well, we took 1 sock out here. So there's only 19 left. And we took out a red sock here, and they want us to pull another red sock out. Well, we took one out from this, so it should be a 5 are left, right? If we took 1 red sock out to begin with. All right, so if you could simplify these, that's fine. If you didn't, I'll just do it here, but you should get a lower number. Let me multiply these out here. 6 times 5 is 30, and 20 times 19 is 380. And if you look at this number, you can divide these both by 2, right, at least, or at least by 10 if they both end in a 0. What would have been better is if you probably divided this out. That would have helped you. So if you said 3 over 38, that's pretty good. Or sorry, yeah, 3 over 38, that's pretty good. I think that's it. I think it's as simple as it gets. I divided both by 10. So, all right, let me do one more. I guess I'll just stay on par with this left side. Without looking, randomly pulls out a purple sock. So there's still 20 socks. And he pulls out a purple one, so that's 10 over 20. Why don't you just make that 1/2? Come on. And then randomly pulls out another purple sock. Okay, so we pulled out one. Well, I'll stay in vein of the first one. We pulled out a red sock, so that should take out, or sorry, purple sock. So that should pull up the 9. And we have 1 less sock, so it should be 19. So it's very similar to last time. This doesn't always change on top, but if anything got taken out, you should definitely subtract 1 from here. This might not change, though. This might stay the same number, if that makes sense, or whatever. For the other 2, probably. And that would be kind of it. So I already simplified that. That'd probably be pretty good to do right there. 9 over 38, I think, would be the probability. Looks good. All right, yeah, these are all dependent variable events. All right, let's do, we only got 2 more. All right, so I'll do the left one. Maybe you do the right one. You randomly select 2 cards of standard playing deck 52. Playing cards. What's the probability that both cards are hearts? When? So hearts, that's the suit. There's 13 total hearts in the playing deck, right? That's also 52 divided by 4 because a fourth of the cards are hearts. You replace the card before each selecting the next one. So we got 2 cards. We're going to pull the first one is 13 out of 52. I also mentioned that was 1/4, right? And then you're going to put it back, replace it, and then you're going to do a 13 out of 52 pull again. Isn't that 1/4 also? So you could just say it's 1/16. Otherwise, you got to multiply these out to be a pretty big number. If you did, you could probably simplify it to 1/16 somehow. So, but yeah. I think let me give you the decimal so you see if you did it right. 1 divided by 16 is, it should say 0.625, or, you get, say, 6.25%, whatever floats your boat there. And then what if we didn't replace it? What if I didn't put it back? Well, we said 13 out of 52, 13 out of 52, right? Well, obviously the first one's still going to be 13 out of 52 for the heart pull. But if I took a heart out, just similar to the sock problem, I took 1 heart out, so I only have 12 left, and I took a card out, so I have 1 less card. And now I have to multiply these out. And same thing before. I could say this is 1/4 and 12 over 51. Does 3 go into 51? 51 divided by 3. It does. So technically that second one could be simplified. Let's see. Let me try to do this real quick. You guys are coming in. 204 and sorry, that's down low. And what's that? 12. So I'll just leave it here. But the decimal should be 204. About 0.05. It's 8. Some other stuff. Honestly, I'll try to do this one. You gotta, you know what? I'm gonna leave it. You could probably try this based off of what we've shown before, though. This is probably a pretty good one for you to try on your own and then see if you get the right answers. When you're done with this, I'd say go back to the practice and start trying some of these, though. Okay, I'll leave these up online, all the answers here. So, all right, good luck, everyone. Until next time.